When you hear nuclear waste, you probably picture a glowing green barrel, dangerous, untouchable, and buried forever. But that image is more fiction than fact. What if I told you that so-called waste is actually packed with untapped energy? Spent nuclear fuel still holds about 95% of its original energy, enough to power cities for centuries. Instead of seeing it as garbage, imagine it as a resource waiting to be unlocked. We recycle plastic and glass. Why not nuclear fuel? The technology to recycle used nuclear fuel exists and can turn what we call waste into clean electricity. Let's set aside the old myths and explore how nuclear waste could be the key to a sustainable energy future. We'll look at what nuclear waste really is, why it's so valuable, and how we can use it safely. By the end, you'll see that the glowing green barrel is just a myth. The real story is a powerful solution hiding in plain sight. To reuse nuclear waste, we first need to know what it is. In a nuclear plant, uranium fuel rods split atoms to make heat and electricity, no carbon emissions. After a few years, these rods are called spent fuel, but 95% of their energy remains unused. Most of what we call waste is still uranium, and other elements like plutonium, still full of energy. Conventional reactors only use a tiny fraction of the fuel, leaving the rest behind. It's like eating just the chocolate chips and tossing the cookie. Spent fuel is highly radioactive, so it's stored in water pools to cool and shield radiation. But most of it isn't garbage, it's unused fuel. Understanding this changes everything. It's not just waste, it's a massive energy resource. That's the first step to rethinking nuclear energy. Right now, spent nuclear fuel is piling up at power plants worldwide. First, it's stored in deep water pools to cool and shield radiation. After several years, it moves to dry cask storage, massive sealed steel and concrete containers. These casks are safe and robust, but they're a temporary fix. The long-term plan has been to bury waste deep underground, but building permanent repositories has proven difficult and controversial. Billions have been spent, but no country has opened a permanent site. This storage dilemma fuels public fear and opposition to nuclear power. But what if, instead of burying this material, we used it? Recycling spent fuel could generate huge amounts of clean energy and shrink the volume and danger of final waste. It flips the problem into an opportunity. The solution is right in front of us. Recycling nuclear fuel isn't just a dream. It's been done. The Integral Fast Reactor (IFR) program in the 1980s and 90s proved it could work. The IFR used fast neutrons to recycle spent fuel, turning waste into electricity. It was designed as a closed fuel cycle. Used fuel was reprocessed on-site and reused. The IFR also demonstrated walk-away safety. If it overheated, physics would shut it down automatically. Despite its success, the program was cancelled for political reasons, not technical ones. But the science and data survived. Today, new scientists and companies are reviving fast reactor technology, building on the IFR's legacy. The reactor that could, still can. The knowledge is there, we just need to use it. The future of clean energy is already proven. So how do fast reactors turn nuclear waste into power? Unlike conventional reactors, fast reactors use high-energy neutrons, no moderator needed. These fast neutrons can split not just uranium-235, but also plutonium and other actinides in spent fuel. That means the waste from old reactors becomes perfect fuel for fast reactors. Spent fuel is reprocessed. Usable actinides are separated and made into new fuel. In the fast reactor, these elements are split, releasing heat to generate electricity. The process reduces the volume and lifespan of radioactive waste. Fast reactors close the fuel cycle, turning yesterday's waste into tomorrow's power. It's a game changer for clean energy. The IFR's legacy lives on in a new wave of companies. Startups like Oklo and TerraPower are building advanced reactors to turn nuclear waste into clean energy. Oklo's Aurora reactor is small, factory-built, and runs on recycled fuel for decades. TerraPower, backed by Bill Gates, is developing the Natrium reactor, combining fast reactor tech with energy storage for flexible, reliable power. These companies are moving beyond paper designs. They're building real reactors, navigating regulations, and forging partnerships. Their goal isn't to replace renewables, but to add a crucial tool to our clean energy toolkit. Imagine fleets of small, safe, waste-eating reactors powering communities and industries. They're turning proven science into real-world solutions. The future of nuclear energy is innovative, practical, and happening now. Science is becoming reality. Safety is always the big question with nuclear power. Accidents like Chernobyl and Fukushima haunt public perception, but those were old designs with outdated safety standards. Modern reactors, especially fast reactors, are built with passive safety. They shut down automatically if something goes wrong. The IFR proved this. No power, no problem. The reactor safely shut itself down. What about nuclear waste and weapons risks? Fast reactor recycling uses methods like pyroprocessing, which keeps plutonium mixed with other radioactive elements, making it unusable for weapons. Every energy source has risks, but nuclear's safety record is among the best. Fossil fuels cause millions of deaths and drive climate change. Even renewables have environmental impacts. Data shows nuclear is one of the safest ways to make reliable electricity. With strong regulation and continuous improvement, modern nuclear is safer than ever. The facts speak for themselves. What does all this mean for our energy future? Climate change demands we decarbonize electricity, and fast. Renewables are vital, but they're intermittent. The sun and wind aren't always there. Advanced nuclear, powered by recycled fuel, can provide clean, steady power 24/7. Recycling spent fuel could power the US for centuries, with no new mining or emissions. It shrinks waste and reduces how long it needs to be stored, from thousands of years to just a few hundred. Clean energy isn't a competition, it's a team effort. By embracing nuclear recycling, we unlock a vast, carbon-free energy source and solve the waste problem. It's a win for the planet and for us all. We've seen that nuclear waste is really untapped fuel, and fast reactors can unlock it. The technology is proven. The challenge now is building it. The main obstacles are no longer technical, but social, political, and economic. We need updated regulations, investment, and public support to bring these reactors online. Most importantly, we need to change the narrative. Nuclear energy is part of the solution, not the problem. Education and outreach are key to busting myths and building trust. The path forward is clear. Recycle nuclear fuel, cut waste, and power our world with clean energy. Scientists and engineers have done their part, now it's up to us. As citizens, policymakers, and investors, we can support this vision. The power is there, waiting. Let's use it.